Okay, so our standard form should be y equals ax squared plus bx plus c, just like we saw it back in Unit 1 when we were factoring or when we were solving using the quadratic formula. Okay, so that is now standard form. There are some pieces to standard form we need to talk about before we go into what's there in our take note box there. I want to do a little extra example here. So I want to first start out by writing a equation of a parabola in vertex form. So vertex form, let's make it y equals 3 times x minus 1 quantity squared plus 2. Okay? So that's written in vertex form. What I want to do now is I want to use our algebra skills to rewrite this in standard form. So to write this in standard form, I need to multiply x minus 1 squared. So that means I take x minus 1 times x minus 1. So I've got to FOIL that, right? So that gives me x squared minus x plus 1. So if I combine my like terms, I now have y equals 3 times x squared minus 2x plus 1 plus 2. Everybody with me so far? Yeah. Okay, so now what I need to do is I need to distribute the 3 through that. So y equals 3x squared minus 6x plus 3 plus 2. So now our last step would be add the like terms. So y equals 3x squared minus 6x plus 5. Okay? That is written in standard form. All right? That's written in standard form. Okay. There are a few things I want you to pay attention to about standard form compared to vertex form. Okay? First off, looking at vertex form, what is the value of a? 3. Right there. That's our a value in vertex form. Now, standard form, remember, standard form is ax squared plus bx plus c. What's our value of a in standard form? 3. It's the exact same thing. Okay? The a in vertex form is the exact same number as the a in standard form. Please remember that. Also remember, a tells us whether it opens up or down, right? Well, it's the same thing. So, if a is positive, that means this parabola must open up. Okay? Something else that standard form gives us. Not only does the a value be the same between the two forms, but if we went through and looked for a y-intercept, what is the coordinates of every y-intercept in the world? Oh, which one's 0? The x is 0. Every y-intercept in the world has an x-coordinate of 0. Okay? Well, if we go through and say, all right, well, let's find out what our y-intercept is for this parabola, I would take 0 and plug it into my standard form. So 0 squared is 0. What's 0 times 3? 0. 0 times negative 6? 0. So I've got 0 plus 0 plus 5. What do I get? 5. I get 5. Hey, take a look at that. 5. It's right down there. Standard form gives us the y-intercept. Always, every time. The y-intercept is always the constant term at the end of the equation. It's always the c value. Now that was true back with lines as well. When we dealt with lines, we had y equals mx plus b. b was always just a number, right? It's called the constant. The constant was the y-intercept. Same thing here. The number at the end, the constant, is the y-intercept. Okay? So we've talked about two things so far. We've said that the a value from vertex form is the same as the a value in standard form. We've said that the constant in standard form is our y-intercept. Okay, that constant number at the end is our y-intercept. There is one more thing that we need to be able to do, and that is to find our vertex. So if you look back at this box, it gives you all sorts of information here, but boy do they make it look confusing. There's really one thing out of all this that you need to know, other than what I've already told you off to the side, and that is this equation right here. They say that that is from, or that is the equation of the axis of symmetry. X equals negative b over 2a. Well, and they're right. But remember from your work the last 2 days, our value or our equation of the axis of symmetry comes from where? The vertex. It's always which coordinate? Which coordinate of the vertex gives us the axis of symmetry? Yes. The x. The axis. It sounds like an x. The axis of symmetry is the x value. So therefore, that equation, x equals negative b over 2a, that is the x coordinate of your vertex. That you need to know. The x coordinate of the vertex is negative b over 2a. Okay? Now, there is a nice thing to help you remember that. Let's see, I want to squeeze this in somewhere here. I'll squeeze it in right down here. You guys don't necessarily need to write this down, but it is a nice way of remembering that the x-coordinate of your vertex is negative b over 2a. Remember way back in Unit 1, we dealt with a formula that helped us solve quadratic equations. It was called the Quadratic Formula. Anybody happen to remember that off the top of their head?
X equals 9 plus or minus the square root all over 2a.
Oop, careful.
I think I missed something.
You did, but that's all right. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay, and what did I just tell you that the x-coordinate of your vertex was? Negative b over 2a. It's right there in the quadratic formula. That right there is your x-coordinate of your vertex. X equals negative b over 2a. Okay? So, let's go back for just a moment to the extra example I'm working over here. So if I know my y-intercept now, I know my standard form of the equation now, I want to use that standard form to find our vertex. So I need to use x equals negative b over 2a. Well, what's the b value in that equation, in that standard form? Negative 6. Remember, it's ax squared plus bx plus c. So b is negative 6. So I've got negative 6 over 2 times, what's a? So that gives me 6 over 6 or 1. So the x-coordinate of our vertex is 1. Now to find the y-coordinate, it is just like we did the last 2 days. where we were just plotting points, right? We picked values of x, plugged them back into the original to find our value of y, right? Well, that's all we're going to do here is take that value of x, 1, and plug it back up into our equation. So y equals 3 times 1 squared minus 6 times 1 plus 5. Well, 1 squared is 1, 3 times 1 is 3, negative 6 times 1 is negative 6, plus 5. So 3 minus 6, it's negative 3, negative 3 plus 5, positive 2. So our vertex is located at 1, 2. Cool. Well, let's see if we're right. Look back up at vertex form. Where's your vertex located? 1, 2. All right. This example here is kind of to show you how things are connected. Okay? I would never, ever, ever ask you guys to start at vertex form, change it to standard form, and then give me the vertex. That's a whole lot of work to work in a big circle when you start in vertex form. You know what the vertex is. Okay? What I will ask you to do is to start in standard form and give me the vertex form. Okay, so I'll teach you how to do that here in a few minutes. Okay? Are there questions about standard form and the items that it gives you? Standard form gives you the A value from vertex form. Standard form gives you the y-intercept. And we can find the x-coordinate of our vertex using negative b over 2a. Those are the three big things you need to take away from what I just talked about. Okay? Questions? Let's try graphing one of these guys. All right, so our first example here is y equals x squared plus 2x plus 3. So the first thing I want to do here is I want to find our vertex. So the x-coordinate of our vertex is located using negative b over 2a. So what's b?
1. 2.
B is 2. So we have negative 2. What's a? 1. So we've got negative 2 over 2, which gives us an x value of negative 1. Well, now we need to take that and find our y-coordinate by plugging back in to our equation. So I've got negative 1 squared plus 2 times negative 1 plus 3. Well, negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. So what do we get? 2. So our vertex is at negative 1, 2. Well, if our vertex is at negative 1, 2, where's our axis of symmetry? How do I write that? X equals negative 1. Just like always, it's always the x-coordinate of our vertex. Okay? Now, what was the a value again? A, 1. A is positive, so this parabola opens up. And since this parabola opens up, our vertex is at the bottom of the trough, right? That gives us a minimum value. So our minimum is located at y equals 2. The minimum value of our equation is 2. There's one more thing we can pull from our equation, and that is our y-intercept. Well, the y-intercept always has an x-coordinate of 0. What's going to be the y-coordinate? 3. The y-intercept is always the constant term. So we can now graph our parabola. We have an axis of symmetry at x equals -1. So this is our vertical axis of symmetry. Our vertex is located at -1, 2. We have a y-intercept at 0, 3. And we still need to plot one more point. Okay, remember, we like to have 2 points on one side in order to graph this. So we have our y-intercept at, not y-intercept, our axis of symmetry, or our vertex at -1 on the x-axis. We don't want to plot 0 because we already have that point. So we're going to go over here to 1. We just make a little t-chart and find out, well, if x equals 1, what does y equal? Well, y equals 1 squared plus 2 times 1 plus 3. 1 squared is 1, 2 times 1 is 2, plus 3. What's our y value? 6. So we have a point at 1, 6. Well, mirror those to the other side. 2 units away from the axis of symmetry, 2 units on the other side gives us a point here. The other point is 1 unit away from the axis of symmetry, so it gets mirrored there. And then we draw our parabola. Questions on this guy? This example here, we're going to work it the exact same way. Okay? Do not vary from what we just did. Okay? So we have a quadratic equation written in standard form. So therefore, we need to find the vertex by using what little equation? X equals -b over 2a. So x equals -b over 2a. What's our b value? 2. So we have -2 over 2 times, what's our a value? -2. So we have -2 over -4. That gives us a value of 1/2. All right, well, we got fractions. That's no big deal. We can still work with fractions. We got to take that fraction and plug it back into the original equation. So y equals -2 times 1/2 squared plus 2 times 1/2 minus 5. Okay, 1/2 squared. That means 1/2 times 1/2. 1/2 times 1/2, we're multiplying fractions. It's 1/4. When you multiply fractions, you multiply straight across the top, 1 times 1, straight across the bottom, 2 times 2, it gives you 1/4. So we have y equals -2 times 1/4 plus, what is 2 times 1/2? 1. 2 times 1/2 is 1 minus 5. Okay, well, we still have to take -2 times 1/4. Again, think of it as fractions. -2 over 1 times 1/4. So we got -2 times 1, we got 1 times 4. What do we get? Reduce it down. -1/2. It's all the same thing. You need to get used to working with fractions, though. Fractions don't go away. They are everywhere. Okay? Another way of looking at that is if the bill, if you go out to eat with your friends and your bill is $2, and there's 4 of you and you need to pay 1/4 of it, how much are you paying? 50 cents. 1/2. $0.50, right? We've got to know how to work with fractions. 1 minus 5 is negative 4. So negative 1/2 minus 4 gives us negative 4.5. I am okay with a mixed number here because the only time I'm using that is for a coordinate. I'm not plugging y back into an equation. I'm not going to be multiplying by negative 4.5. All I'm doing is using that for a coordinate. That is the y coordinate of our vertex. So there's the vertex. That means our axis of symmetry is located where? Axis of symmetry is at 1/2. This parabola opens down because a is negative. So therefore our maximum value is negative 4.5. The other thing we can pull from the equation is what? The y-intercept, which is located at 0, negative 5. It's always the constant term in your equation. So let's graph what we have. Our axis of symmetry is at x equals 1/2. So go to 1/2 on the x-axis and draw a vertical line. Again, just because we have fractions does not mean we change anything in how we do this. Our vertex is at 1/2, negative 4.5. So I go down 4.5. Brings me to a point right about there. We know that we have a y-intercept at 0, negative 5. So I'm going to plot that point. Okay. I've got 2 points. I still need one more. Now notice, I've already got a point on the left side of my axis of symmetry. So let's pick one more on the left side of the axis of symmetry. What x value am I going to pick? Negative 1. So y is negative 2 times negative 1 squared plus 2 times negative 1 minus 5. So negative 1 squared is 1. 1 times negative 2. 2 times negative 1 is negative 2 minus 5. So what's our y value? Negative 9. So there is another point. When x is negative 1, y is negative 9. Okay, before I finish this problem, I want to zoom in here a little bit, make sure everybody understands what I'm doing as I graph this guy. So to graph this, I need to mirror those things to the other side of my axis of symmetry. This point here is half a unit away from the axis of symmetry. So it gets reflected half a unit to the other side. So I've got a point sitting there. This point here is 1.5 units away from the axis of symmetry. So again, it gets reflected 1.5 units to the other side. And now that we have our 5 points, we can draw our parabola. On the back side here, some of these examples deal with fractions. At this stage in the game, I don't want to do an example of fractions. I want to do an example just with some easy numbers to work with so that you can see the process, okay? So that being said, I would like to look at this example here. Y equals x squared minus 2x plus 9. I want to rewrite that in vertex form. There are 2 ways to do this. I want to show you both. So, the first way of going about this is to simply find our a value and find our vertex, just like we were doing yesterday. Yesterday's homework, they gave us the vertex. we had to find the a value in order to write the equation in vertex form, right? Well, in this particular problem, they actually give us the a value because they give it to us in standard form, right? The a value is the same between standard form and vertex form. So our a value is 1. Well, now we've got to find our vertex. So to find the vertex, we know the x-coordinate of our vertex is negative b over 2a. So we've got to solve for that. So that's negative 2, that's our b value, over 2 times 1, because that's our a value. Negative 2 is 2. And 2 times 1 is 2. So our x value is 1. Plug that back in to find y. 1 squared minus 2 times 1 plus 9. So we have 1 minus 2 plus 9. Gives us a y value of 8. Well, that's all we need. We need our coordinate of our vertex, which is now at 1, 8, and our a value. We can write this then in vertex form. Y equals, now since a is 1, do I have to write a 1 out in front? No, I don't need to write that out in front. So y equals x minus 1 quantity squared plus 8. Vertex form showing that our vertex is at 1, 8. Okay? Questions on doing that? That is one method you can use. It will always work. It is super nice to know. Now, I would not be a good math teacher if I didn't show you the other method we have. You've seen this other method before. Okay? Sometimes it might be easier. Some people think it's easier. It is all up to you what you think. So, this other method we've done before, it's called completing the square. Okay? So, if I complete the square, I'm starting with my basic standard form equation. This is the squared term, right? So I want to make this side a perfect square trinomial. So in order to do that, I've got to get rid of the 9 first. So I'm going to subtract both sides by 9. Well, now, in completing the square, I've got to add a constant to both sides that makes my left side there a perfect square trinomial. So I've got y minus 9 plus something equals x squared minus 2x plus something. Well, hopefully you guys remember from Unit 1 when we did completing the square, this trinomial is going to factor into x plus or minus something quantity squared. How did we get this value? We took half of the negative 2, which is negative 1. And then we got this number by squaring that negative 1. So negative 1 squared, positive 1. So we're adding 1 to both sides. Well, what's negative 9 plus 1? Negative 8. Well, our equation should say y equals, so I got to get rid of that minus 8 by adding 8 to both sides. And again, there's vertex form. Both methods work. It doesn't matter which one you use. But of course, if you're choosing to use the completing the square method, you have to remember how to complete the square. Okay? You've got notes on that. I've got videos online for that. If you choose to use that method, make sure you know how to complete the square properly. Okay?